It was once the fantasy of sorcerers and sci-fi, the dream of vanishing into thin air. Not just hidden from sight, but from detection itself. For centuries, invisibility was considered pure illusion. But now, physics is catching up to myth. The question has shifted from if to how soon, and the answer may lie in one of the strangest frontiers of modern science, quantum cloaking. Let's be clear, traditional stealth has already come a long way. Radar-absorbing paint, edge-aligned airframes, active noise cancellation, all designed to scatter, absorb, or deflect detection. But these are static techniques. They work for a specific band, from a specific angle. They're vulnerable to multi-sensor fusion, synthetic aperture radar, and, more recently, quantum radar. Quantum cloaking aims for something far more radical, not to avoid being detected, but to make detection physically impossible. The foundation is metamaterials, man-made structures engineered to control the flow of electromagnetic waves at scales smaller than the wavelength itself. But to make true cloaking possible, these materials must do more than bend radar. They must manipulate light, heat, sound, and even quantum states. One concept gaining momentum is the transformation optics cloak, a theoretical framework using Maxwell's equations to guide electromagnetic waves around a region of space. Imagine light traveling around an object as if the object wasn't there. The energy re-emerges on the other side without distortion, making the hidden zone undetectable. But metamaterials alone aren't enough. That's where quantum mechanics enters. Researchers at the University of Rochester have successfully demonstrated a primitive, temporal cloak, using a phenomenon called four-wave mixing. By manipulating the phase velocity of light through a nonlinear medium, they created a time gap in which an event, a brief change in the beam, was rendered completely undetectable. The light recombined as if the event never occurred. It's like editing a frame out of a movie, but in real time, with no cut line. Simultaneously, quantum entanglement offers another path. Quantum illumination, originally designed to detect stealth objects, can be reversed. By controlling entangled photon pairs and orchestrating destructive interference in reflected signals, it's theoretically possible to cancel out return echoes from an object. You're not just absorbing light, you're using quantum noise to erase your own shadow from the sensor. DARPA's REVEAL program has been pushing this envelope, exploring materials with tunable refractive indices, controlled by quantum states, that can dynamically shift how they respond to incoming signals. Think of a cloak that adapts on the fly, changing its electromagnetic signature as radars sweep through different frequencies. At the cutting edge, researchers are investigating quantum metasurfaces, ultra-thin layers composed of subwavelength resonators coupled with quantum dots or nitrogen vacancy centers in diamond. These structures can be engineered to respond to specific quantum field modes. When stimulated, they either scatter incoming waves destructively or delay them to confuse detection systems. Essentially, they can jam your quantum radar without emitting any signal themselves. China's defense research community is reportedly pursuing a variation using topological insulators, materials that conduct electricity only on their surface but remain insulating internally. When paired with strong spin-orbit coupling, these materials can manipulate terahertz waves to render specific objects invisible to millimeter-wave scanners, even while those objects remain warm or moving. There's also growing work on active quantum cloaking, using machine learning models fed with real-time quantum state data to control surface emitters that mimic the background environment, effectively erasing the thermal and electromagnetic contrast of the object. A quantum object that actively impersonates the void. Still, there are obstacles. Quantum coherence is fragile. Decoherence, the collapse of quantum states due to environmental interaction, is the Achilles heel of many proposed designs. Most working prototypes only function in controlled lab conditions, often at cryogenic temperatures and over narrow bandwidths. But the pace of progress is staggering. Even partial quantum cloaking, for instance, masking a submarine from low-frequency sonar during launch, or shrouding the thermal bloom of a hypersonic glide vehicle for just 10 seconds, would be enough to tilt a strategic balance. That's why defense agencies worldwide aren't waiting for perfection. Russia's Institute for Theoretical and Applied Electrodynamics has published research on photonic crystals designed to reroute laser guidance systems. The EU's quantum flagship has invested in cloaking applications for satellites. And private firms in Israel and Singapore are developing portable metamaterial shrouds for drone fleets, able to suppress radar cross-section signatures in combat theaters. So where are we now? Today's quantum cloaks are primitive, short-lived, small-scale, and highly sensitive. But they're proof that the laws of visibility, once immutable, are now being rewritten. Invisibility may not be permanent. It may not even be total. But in warfare, moments matter. A second unseen is a second undefeated. If you're enjoying this series uncovering the quantum frontier of defense technology, hit that like button now and subscribe. It helps more than you know, and ensures you'll stay ahead of the curve as science bends reality itself. Because this story is no longer just about hiding from sensors. It's about hiding from the very rules that govern detection. About stepping into the folds of physics and emerging unseen. In our next episode, we'll explore the other side of this coin, how quantum-enhanced medical technology, initially developed for battlefield triage, could be used to scan wounds, diagnose trauma, and even deliver drugs with atomic-level precision in real time. The quantum revolution isn't just about cloaking and conquest. Sometimes, it's about clarity and healing. Stay tuned.